last time we were kind of running through some of these relationships, and I pointed out a couple things here. The speed of an object in parametric, like 2 space, is the resultant vector, essentially. It's the Pythagorean theorem with the 2 components is what it boils down to. Hopefully that looks like the Pythagorean theorem to you. So that would be the speed, also known as the magnitude of the velocity vector. This is where it gets a little bit more interesting. The angle, and I'm going to add a little bit of a specific direction here. The angle with respect to horizontal. The angle with respect to horizontal at some time t equals a is equal to the inverse tangent of dy dx. And again, it's important to note that that's the angle with respect to horizontal. It's not whatever angle you want it to be, specifically with respect to horizontal. So let's take a look at that. So if we had some object moving along, doing something like that, and we had some point picked out, maybe like right here, and we wanted to know the angle that the particle was taking there with respect to horizontal. So this would be horizontal right here. And then, of course, the angle would be something like that. Well, then this side would be the differential of y. This side down here would be the differential of x. Then the angle in here, which is we could call theta, that angle right there, if you think about it, it would be tangent of that angle equals dy over dx. Therefore, if you take the inverse tangent of both sides, you get theta equals the inverse tangent of the derivative of dy dx. So again, that's the angle with respect to a horizontal relationship there. So that'll come into play. And then finally, the distance traveled, so total distance traveled by some object cruising around on the xy plane, going curvy and up and down and left and right and all around, is equal to this. And then it's important to note, of course, that this is the exact same formula as what? Parametric length of a curve, yeah. So the parametric length of a curve is the same thing as total distance traveled. So again, there's not a new formula for that to be memorized, just making that connection between the two and realizing that it's describing the same thing. Okay. Questions, concerns? All right, so let's do some examples. So you can refer back to that page if you want to help you know what to do. But the hope is that you know enough about derivatives and integrals and things like that to give you some direction on all of these. Okay, so with all of these, I try to give you some instructions about no calculator, yes calculator. Please do follow those, because if you use a calculator when you shouldn't, it's going to make the problem seem very different than if you followed the instructions. So consider those. So number 1 is no calculator. It says particle moves in the xy plane so that at any time t, the position is given by x of t and y of t. So x of t would be the x coordinate for the position, y of t would be the y coordinate for the position, and you're given the relationships there. 1a says, find the velocity vector when t equals 1. Find the velocity vector when t equals 1. I thought I would do this one with you just to help you with the symbology a little bit. Then I think you'll find B, hopefully at that point, to be very doable. So we know that the velocity vector is, there we go, the derivative of the position vector. I do not know why that's being highlighted, but whatever. Okay, so then if I'm going to find the velocity vector in terms of t, I'm just going to differentiate. So the x component of velocity would be 3t squared plus 8t, comma. The y component of velocity would simply be the derivative of the y position component. So t cubed minus 3t squared. And notice I'm using kind of those pointy parentheses. There's probably a better name. I just call them pointy parentheses, whatever. If you use I hats and j hats or i's and j's, if you're used to that from physics, that's totally fine. And we could look at what the answer would be if you did that. But then to finally answer this, the velocity vector at t equals 1, we would just plug in a 1 wherever you see a t. So 3 times 1 squared plus 8 times 1 is 11. And then for the other one, it'd just be 4 minus 3. So your velocity vector would be 11, comma 1 when t equals 1. So which direction is this object going? Up and right. Yeah, up and right. So if you wrote it like this, this is also standard notation. Nobody's going to mark that wrong. But just know that on like multiple choice scenarios, it's always going to be, at least as far as I've ever seen, it's going to be the pointy parentheses as far as AP tests go. So it'd be good if you're not familiar with this sort of notation to familiarize yourself with it. Okay? So that being said, if you guys would try B, please, using a similar process. Forgot to show her the steps. I erased them. I wasn't doing the video. But I bet you she figured that one out.
Yeah, she's smart.
Yep.
Hey. Can you hear us?
That was Josh. Yeah, it's going right now.
Hi.
Is it live?
It's not live streaming. I post it when it's done. And now it's paused. Number 2 says particle moves in the xy plane for non-negative time. Position is given by those two components. Find, and of course, isn't this the key to the whole thing as far as what am I supposed to do? It uses the keywords. Find the magnitude of the velocity vector. What's another word for that phrase? It's a single word.
Speed.
Speed, that's right. So you can approach it either way. It's the same thing. But what you've got to do is you've got the square root of the two components of velocity squared and added together. It's basically just the resultant vector. So it'd be, I'll put it like this, I guess. So dx dt equals 2t plus 3. So dx dt at t equals 1 equals 5, right? And then dy dt equals 3t squared minus 6t. So then evaluated at 1, you get 3 minus 6, which is negative 3. Okay? And then what you're going to do is you're going to find the resultant of that. So we're going to go 5 squared plus negative 3 squared. We're going to square root the result of that. Did you guys get the square root of 34?
Oh, yeah.
Square root of 34. 25 plus 9.
Oh, good math is. Never mind.
Did you mean square root of 36?
It's easy to read 36 into that, right? Sweet, the answer's 6.
I was like, easy.
It's gotta be.
I was like, I know that one.
Hey, question for you. Hey, guys. Question for you. Would I need to consider, like if I did, look at this and be like, all right, there's a square root there. Do I need to consider plus or minus here or no?
No, because
Well, it has to be plus because speed is always positive.
Speed is a
magnitude.
Yeah, speed is technically scalar, right? It's the direction, the positivity, negativity, or the angle is what gives it a direction and turns it into a vector. So we do not need to consider plus or minus of anything.
So would it be wrong if you wrote it like that? I don't know how to explain that in words.
Yeah, velocity. So, well, you know what it'd have to be? It would need to be, you'd need to use this notation.
I wrote it out in words because I didn't know what to say.
absolute value.
Would you still have the little arrow?
Yeah, well, it's not a vector anymore.
Okay.
Right, I mean, if you had the arrow there, I'm fine with that. But it's really not a vector anymore.
Okay.
You're just looking for the absolute value of velocity, essentially,
Okay.
which in 2 dimensions is Pythagorean theorem. It's that distance. Okay, so number 3 then. This one is no calculator again. This one says a particle moves around the xy plane so that the positions are given by those 2 parametric equations for 0 to 2 pi. Particle hits the x-axis twice. Write an expression that represents the distance traveled between the 2 x-intercepts. Do not evaluate. Just write out the expression. Ready, go. For number 3, it says the particle intersects the x-axis twice. Write an expression for the distance traveled between those 2 x-intercepts. It would be probably a good idea to figure out what's going on with those 2 x-intercepts. So when it's something, in this case a particle, hits the x-axis, what else is true? Y equals 0. So I would set the y position equal to 0. So it'd be 0 equals 1 minus 2 sine of t. And this is where our old friend trigonometry would come into play. So it'd end up being 1/2 is equal to sine of t. So you do inverse sine of both sides. And so you'd get t on the right side. What's the inverse sine of 1/2? Pi over 6. Yep, that's one of them. As far as, and of course that's within our domain 0 to 2 pi, so I'm feeling pretty good about that one. But there's got to be at least one more, right? Because if you just keep going around the circle. Say again? 11 pi over 6. No, it's in this, should be in the second quadrant. So I think 5 pi over 6. Okay, so then that would be your times, Brandon? And that should also help you with your limits of integration.
It's a classic.
You guys get something like that? Okay. All right, so if you haven't already looked at number 4, please do, unless there are questions on this. You know, yes. It was just off my screen slightly to the right. I can do all this. I can do this without you seeing it. I didn't see it. It was off screen. I assumed it was a plus. So let's see here. So 1 minus the derivative. Yep, it should be negative. Of course, it wouldn't matter for the, to be honest with you, if you did that, it wouldn't make any difference. You'd still get full credit because it's the same thing. But yeah, technically there should be a negative there. I need to make sure my window is sized right. Okay. Any other questions on that one? Alrighty. So then number 4. So let me say this. I think about number 4, I think half of it is probably relatively straightforward and the other half might be a little bit less straightforward. I think that the x componentry is pretty straightforward. The y is a little bit less so. Think about it like this. If you are given a velocity vector, but then the end goal is a position vector, what tool are you going to have to use along the way? Yay, an antiderivative, the tall skinny s. So maybe we look at it like this and say, all right, for my x, I'm going to say integral from 3t squared, or excuse me, integral of 3t squared plus 4 dt. This would equal my x component. And then I would say this is really t cubed plus 4t plus c is equal to my x position component. And how is it that I'm supposed to find the c? It does give you a point. It tells you that when t equals 1, the position is 2, 7. So importantly for the x, I would say that when t is 1, x is 2. So we would go 2 right there. Everything else is 1s. And I've got 1 plus 4 is 5. Subtracting from both sides, I've got c equals negative 3. And so my position component is going to be t cubed plus 4t minus 3, comma, I don't know the other one yet. To me, that's the straightforward one. When you do it with the y's, things are a little bit different. Immediately, because you say, cool, we'll go integral of natural log of 5t dt equals my y component of position, and you should immediately run into like, whoa, I don't know if I remember how to find the antiderivative of natural log. You guys remember? Yeah, but then the t is a pain, right? It ends up being parts. Use integration by parts. And if you remember, this is the tricky one where your u has to be the natural log. So u has to be this. dv has to be dt. You've got to set it up like that. If part of your integrand is natural log, the u has to be the natural log. V then equals t. Du then equals, surprisingly, 1 over t, right? 5 over 5t by the chain rule. So then you use parts, and you say ultraviolet, so it'd be t ln of 5t minus integral of voodoo. Golly, that's just 1, isn't it? 1 dt. So we end up finally with, and that equals y of t, of course. We end up with t ln of 5t minus t plus c equals y of t. So I kind of snuck one in on you here. You had to use parts, and you had to do kind of the challenging version of parts to do this. The way you find the c is simply to use what we did before. We know when t is 1, position is 7. So 7 equals, it would be 1 natural log of 5 minus 1 plus c. So it looks like c is the lovely 8 minus natural log of 5. So then your component here would be, your y component would be t ln of 5t minus t plus 8 minus natural log of 5 for your y position, or y component of position. So think of that as a little bit of review, kind of spiraled in there of how to do parts again. Probably a good thing, right? Considering parts is on your final, not a bad thing. Yeah, just this year only. Just this year only. Okay, thank you guys for your hard work. You, believe it or not, you will get a chance to review something like that again when I see you Wednesday. Okay? We'll wrap things up on Wednesday for sure. That'll leave you Thursday to be a review day. As far as I know.